analysis of cantilever beam with UDL and point load using ANSYS Workbench. Okay, so here we can see the beam element which is subjected to uniformly distributed load and point load. Draw the shear and bending moment diagram and determine the maximum normal stress due to bending. Here you can see that it is a circular cross section. Previous problem what we solved, it is a rectangular cross section of breadth and height is given. So in this problem they are given the radius. Let us analyze this problem using an ANSYS Workbench. Let us open ANSYS Workbench. First I'll go to the static structural. Right click, engineering data, edit. So now I will give it new material as material 1, isotropic element, select and enter the Young's modulus as well as the Poisson's ratio. The Young's modulus is 210 into E9, 210 E9. The Poisson's ratio is 0.3. Okay, this completes the step number 1. Let's go to the project, geometry, new design, modular geometry. Okay, in this figure we can see that same here also we have it is in meter. I will do it in millimeters. Okay, I will do it in millimeters, and you can check that here the element which I am considering is the same material, so that no need of writing no need of doing the separate lines. Okay, so now what I'll do here, I'll do this problem in millimeters. XY plane, look at units, I'll give it as millimeter. Okay, now go to zoom option, zoom option. Now the first element A to D is 0.25. First I will write the 3 lines here. See, first A to D, D to C and C to B. Okay, so now go to the sketching line. So I'll take a line from first line, because since the same material I'm considering, so I can directly write second line and third line. 3 lines I considered. Now go to dimensions, general. Now measure these lines. This is one line, this is one line, and this is one dimensions. Now give the length of each element here. Now the first is I'm doing in mm, 0.25 meter. Convert it to mm, 250 mm. We'll get it as 250 mm. So I'll give the first element is 250 mm. Second is 1000. The 1 meter is there. I'm converting to millimeter, 1000, 250, 1000, and 250. I'll give H1 as 250. Next 1000, it is 250. I give the dimensions. Now go to the fit command. Okay, so we got a 3 sections now. Now go to the line from sketches. Now give generate. Now line from sketches, go to the concept, line from sketches, select first, control, second line, control, third line, and then give apply, generate. Now we should go we should give the cross section here. It is circular cross section. Go to the concept, cross section, circular. Here you can see that the radius is given as 20 mm. Now I'll enter radius as 20 mm. Now give generate. Now here one part and one body is created. Click here, line body, and select the cross section as circular. Okay, now give generate. Now we want to see the cross section, so that we can go to the view. In view we have an option called as cross section solids. So here go to the rotate option. So here you can see that we have a circular cross section. You can see that we have a circular cross section. This completes the second step. Next is modeling, edit. In modeling, first go to geometry, change the line body element as material 1, as it is arbitrarily it is having the structural steel, so that we have to convert, we change it into material 1. After that we have to do the mesh. Go to the mesh, right click, generate mesh. So the mesh is done. Now we should apply the boundary conditions. Before that, I'll go to static structural. In static environment, before the display I section, so that we'll get the I section. Now I should apply the boundary conditions. Now see here, the first is, it is a fixed, first node is fixed, and from second to fourth node, first it is having the UDL, uniformly distributed load, and at the node number 3 we have a load of 3 kilonewton in negative y direction. First I'll apply the fixed at node number 1. First I'll go to this. Now select the environment, it is fixed. Select the vertex, select the first vertex and give apply, and it is done. You can see that it is fixed. Next, second, I want to apply a UDL. I will apply a UDL from second to fourth node. So how to look at how to apply a UDL. So go to the loads. In loads we have a line pressure. In line pressure, select the first line, control second, till where we require the line pressure. Okay, here vector, give the components, and negative y direction I am applying the UDL, so that what is the value of this one is 2 kilonewton meter. 2 kilonewton meter is minus 2000. In y component I am applying the minus 2000. Now select, give apply. So you can see that the line pressure, the UDL is applied to from the node number 2 to node number 4, from here to here. This is the way how we can apply the UDL. UDL can be applied with the help of the line pressure. Now we have applied the UDL. Now you can see that at node number 3 we have the load of 3 kilonewton negative y direction. Now what I'll do here is I'll go there here, and again I should go to force. In a force I'm selecting the vertex. In vertex we are node number 3 here. 3, I am applying the vector component. Select the component in negative y direction. You are applying a load of minus 3000. 3 kilo means minus 3000. Now give apply. So you can see the boundary conditions, that the first we have the fixed support, and at the B to the D last one we have the line pressure UDL, and at the C third node we are applying a force of 3000 Newton. This completes the boundary conditions. Now before we have determined the solution, so insert, we have in insert you should take the deformation directional deformation. I will orientation is x-axis, we have to change it to y-axis. I'm changing the orientation to y-axis. And again solution, insert beam tool. In beam tool will determine the maximum stress, minimum stress and direct stress. Now I want to shear force and bending moment diagram. So go to solution, insert, you have beam results, you have shear moment diagram. Insert beam results, shear moment diagram. In order to draw a shear moment diagram, we should first identify the path. How to identify the path? First go to the model, right click. In right click, after right click, insert construction geometry path. So here the path type will be 2 points, change it into edge. Changes into edge, and select the, here you select the option edge and select the edges control. Again second edge, and we have third edge, and give apply, so that we can see that path from first to last node. Okay, after this we should go to the total shear moment diagram. Here change the path to a path, and we are determining the type in the directional in y direction. So I'm selecting in y direction, we are applying, and y shear force, you can see that we have y shear force. Now go to the solution, give solve command. Solve command. Next we should go to solution, Here you can see the direct stress, minimum stress, maximum stress, and you can see the directional deformation. Directional deformation, directional shear force and bending moment diagram, and we have a solution information. This is the, if you want to see this view, so this is the view you can see here. This is the minimum combined stress, and this is the maximum stress, combined stress, direct stress, directional shear moment diagram, directional deformation. These are the, we want to see this in Excel. Right click, give worksheet summary.